Hello everyone and welcome to Fisimania. In today's video we're going to be doing another experiment, okay? We're going to be learning about Newton's first law. We're going to be learning about Newton's first law by looking at the relationship between the normal force and the force of friction. So without further ado, let's get started. Our setup for today is going to be composed of a one-dimensional track, a force sensor, a friction pad, and four 1 kilogram masses, okay? We're going to start by moving this cart slowly, okay, with a constant velocity such that there is no acceleration. Therefore, from Newton's first law, the applied force that we're going to exert on the friction pad is going to be equals to the kinetic friction force. Therefore, we're going to see the following force versus time plot. We can see here the force versus time plot, okay, and we see that just right around 1.5 seconds there's a big peak. This peak corresponds to the static friction force, okay, and then the rest, which is almost constant, you see that there's some wiggles around it, but it's basically constant. These wiggles here, okay, this constant behavior is going to be basically the force of friction due to the motion that we exerted on the cart, okay? So basically we're pulling with the force sensor such that the force of friction is going to be equal to the force applied on the pad. Therefore, we can see that the behavior produced is going to be this force versus time plot that we have right here. Now we're going to see how the applied force and therefore the kinetic friction force is affected through the normal force. We're going to start by putting four masses on top of the of the friction pad, and then we're going to be moving and then taking them out at a constant speed. Then we're going to see that we're going to do a difference force versus time plot. And this force versus time plot, okay, has kind of like this shape of four steps. Each of these steps corresponds to the friction pad having different masses on top of it. So for example, the top one corresponds to having 4 kilograms on top of it. Then each consecutive step corresponds to having 1 less kilogram on top of it. And we see that as we have more mass and therefore more normal force, the applied force that we have to apply to the cart has to be greater. Therefore, the kinetic friction force is going to be directly proportional to the normal force. Now, we're going to find the exact relationship between the normal force and the friction force. So, by remembering, okay, that from Newton's first law, in the y-axis, so in the vertical axis, the normal force has to be equals to mass times gravity, therefore the force of gravity. We can find what the normal force is when we have all the way from 0 masses to when we have 4 masses on top of the friction pad card. Then we can also find the applied force, okay, by looking at the force versus time graph that we plotted before. We saw that we had 4 different levels. Therefore, what this means is that we're going to have 4 different applied force for 4 different friction forces. So again, this is using Newton's first law, where we have that we're moving with a constant speed along the x-axis, so the horizontal axis. Therefore, the applied force is going to be equals to the kinetic friction force. And we see, that the values that we can get for the normal force in this case by using this Newton's first law is going to be all the way from 1.33 newtons all the way to 29.43 newtons. And then the applied force is going to be equals to 0.353 newtons all the way to 6.0057 newtons. Now we're going to proceed to select these data points, and we will be plotting the force applied versus the normal force. Therefore, we're going to plot the applied force in the y-axis, and then the normal force is going to go in the x-axis. Now we're going to proceed to put a trend line for these data points, and we're going to put the y-intercept to be equals to 0. We see that our equation is going to be y equals to 0.215 times x. In this case, the y is going to correspond to the applied force, and because of Newton's first law, this means that the y is going to correspond to the kinetic friction force, being equals to that slope for this trend line, and then the x is going to correspond to the normal force in this case. Then we can see that there's actually a directly proportional relation between the kinetic friction force and the normal force. And in this case, because the friction force and the normal force have the same units, what this tells us is that this slope is going to be unitless. And going to our introductory physics class, we see that this slope is going to correspond to the kinetic friction coefficient. So our results indicate that for the friction path, the coefficient of kinetic friction is going to correspond to 0.215 in this case. So for our experiment, this is our value of the coefficient of kinetic friction. And with this, we have reached the end of this video. So I hope you like it, I hope you have fun, and you have learned a lot. See you in the next video.